The greatest common factor, GCF, is just something that you're looking for all common factors that you can remove. Basically, you're looking to see if you were given an expression. So 35x cubed plus, let's say, 45x to the fifth. And you want to find what is the greatest common factor that you can remove from these. Basically, you're looking to see what common factors between 35 and 45, or what factors are shared between those two numbers. So if you look at them, 35 has what prime factors? What's the, if you were to create the factor tree, okay, so you have 5 times 7 are both of those prime numbers. Yeah, so these are your prime factors for 35. When you look at the prime factors for 45, you have, again, if you're thinking 5 times 9, well, is 9 a prime factor? No, that can be factored even further to 3 times 3. So here would be your prime factors for 45 and your prime factors for 35. So if you take all the common ones, what would that be? So 5 it has 5 in common. Is there any other factors that it has in common? No. So when you factor that out or find your greatest common factor, you can remove a 5. And then how many x's can you remove? What's the largest number of x's that are contained in both of those terms? 3. So you can remove an x cubed. So this right here would be your greatest common factor. Greatest common denominator, if it's done in a fraction form. The reason I bring this up is it's located on your calculator as this, GCD. And so if you have like a set of numbers and you're uncertain what the prime factors are that they have in common, so if you didn't want to go through this process of finding what are the common factors of this, what you could do is you could take those two numbers and you can use GCD of your calculator to find what the common factors are. And you can either type in GCD if you want, and so you can alpha lock and then type in the GCD, or the place that it's located on your calculators, if you wanted to do this, is this math key. So if you hit second function and then the number 5, it's the same place where absolute value is located. So then you go to number. And now you can either scroll up or down. I'm going to scroll up because I know it's close to the end, and it's right here, GCD. Okay, but you can just type the letters in if you want to. And then you just enter what you have, 35 and 45, close it off, and it tells you 5 is your greatest common factor for those numbers. All right, now what if you wanted to do more than 2 numbers? This command only works for 2 numbers. Okay, so if you wanted to do, let's say, 35, 45, and let's say 15, you couldn't just add the number 15 in here. It's not going to do it. It tells you, it'll give you that error message. What you would have to do if you wanted a third one or a fourth one or whatever, is you'd have to embed one set within the other set. So basically, if you wanted to find the greatest common denominator or the greatest common factor of 35, 45, and 15, what you would have to do is you'd have to group them into 2s. So you'd find the greatest common denominator of, let's say, 35 and 45. And then what you'd have to do is embed that completely inside of another GCD of this number, and then the last one, 15. So this is what it would actually look like in your calculator if you were doing that. And you would take the greatest common denominator. I'm just going to go up and copy this real quick. Of, and then you'd have to take the greatest common denominator. So under math, number, letter C. And then so you embed this first one, 35 and 45, close that off, separate with a comma, so that's this whole piece. And then I wanted to add the 15 to it and close that off. And so now I'm still working with just the 2, but one's embedded in another. And it does tell you 5 is the greatest common factor that you can remove from all 3 of those terms. Okay, this shouldn't be a huge issue. I don't foresee them giving you a lot of problems where this is the main point of it. And here's what the main point is to identifying this greatest common factor, is when you're asked to factor an expression completely, it'll usually be something that's similar to this as far as the complexity goes. And when you do this, if you look to see, you have 3 terms here. And number-wise, just start with the smallest number, 3. It's a prime number by itself. So can you take a 3 out of 30? Can you take a 3 out of 27? Yeah, so there's your greatest common factor from the numbers. And then what's the largest number of x's that are shared by all 3 of those terms? So what that means is when we write what's going to remain inside here, we'll have to have the exact same form that we had in the original. Something plus something else plus something else. It's going to have that 3 terms, or that trinomial. Okay, so if we divide each of these individual terms by 3x squared, that's going to tell us what's left in these parentheses. So what is 3x to the 4th divided by 3x squared? The 3's cancel, and 2 of these x's cancel, leaving x to the 2nd. And then when you divide 30x cubed by 3x squared, what's left? 3 goes into 30 10 times, and these 2 x's cancel with 2 of these, leaving an x. And then 3 goes into 27, how many times? 9, and the x squareds cancel. And so you're left with this form. Once you remove your common factors, then you can apply any of the other factoring rules that we have. So we did already talk about reverse foiling. Are there 2 factors of 9 whose sum is positive 10? What factors of 9 have a sum of positive 10? Plus 1 and plus 9. Okay, so those are going to be our terms when we complete these factors. So once again, I wanted to show you how to do it by hand, but the easiest way to solve this for you guys would be enter it in your calculator, the algebra tab F2, hit factor number 2, type the expression 3x to the 4th plus 30x cubed plus 27x squared. Close it off, hit enter, and you see 3x squared, x plus 1, x plus 9. And it calculates, finds your factors for you much quicker than if you're doing it by hand. And the last thing to go through is, again, solving one of these problems. So try to solve this really quickly, come up with what the solutions are for x. So if you do the solve, F2, hit number 1, solve, type your equation, 7x cubed minus 63x. Set that equal to 0 and solve for x. And I'll have my answer. My answers are negative 3, 0, and 3. Okay, now if you did this by hand, again, which you don't have to do, but I want you at least to be exposed to this, you would remove your common factor first. Numbers-wise, are there any common factors between 7 and 63? Let's take out the 7. And then how many x's can you take out? Now the smallest one is 1. And so when you divide this first, so what's going to be left in here, we'll have 2 terms separated by a minus. So when you take out a 7 and an x from 7x cubed, what's left? Well, the 7's cancel, leaving x to the 2nd. Remember, we took out this set, the whole 7 and one of the x's. And then when we take a 7 out of negative 63, what are we left with? 9. And when we take an x out of x, that cancels. And so here would be our leftover function. And now we have the difference of 2 squares. What values, what bases are being squared here? X and, to get 9, we square 3. So we're going to take the sum and difference of those. And when we set each of these factors equal to 0, we solve. Here x equals 0, here x equals negative 3, here x equals positive 3. And you can see these are identical, confirm what we got by using the calculator.